Section 5.3, Shapley-Shubik power. Before you go any further, please pause the video and go to Section 5.3 in our textbook and write out the following definition. Sequential coalition, an exclamation mark, which is read n factorial, pivotal player, pivotal count, Shapley-Shubik power index, Shapley-Shubik power distribution. In this section, we learn about an approach to measuring power, first proposed by mathematician Lloyd Shapley and economist Martin Shubik in 1954. The main difference between this method and the Banzhaf measure of power is the concept of a sequential coalition. Shapley-Shubik assumes the players join a coalition one person at a time. This means that their coalitions are not just a collection of players in a coalition. Each coalition lists the players in the specific order that they joined the coalition, and order matters. In other words, the coalition P1, P2, P3 is different from the coalition P2, P1, P3 because the order is different. This means that there are many more different possible coalitions. Also, in this method, we only list the coalitions that have all n players in them. Example, what would be one three-member coalition under Banzhaf would be 6 different sequential coalitions under Shapley-Shubik because there are 6 different ways to arrange 3 members in different orders. We need a new symbol for this. N factorial is the number of different ways a set of size n can be arranged. N factorial equals 1 times 2 times 3 times 4 times up to times n. For example, 3 factorial equals 1 times 2 times 3, which is 6. 4 factorial equals 1 times 2 times 3 times 4, which is 24. How to compute a Shapley-Shubik power distribution by hand. List all possible coalitions. Remember that we only want coalitions that include all of the pivotal players. There are n players. If there are n players, there will be n factorial coalitions. Step 2. Find the pivotal player for each coalition and underline the pivotal player. Step 3. Find the pivotal count for each pivotal player. SS1 is the pivotal count for player 1, SS2 for player 2, and so on. Note, each Shapley-Shubik coalition has one pivotal player, and there are n factorial coalitions, so the total pivotal count is always n factorial for Shapley-Shubik. Step 4, compute all of the Shapley-Shubik power indices sigma 1, sigma 2 up to sigma n. For example, the index for player 1, sigma 1, equals the pivotal count for player 1 divided by n factorial. The index for player 2, sigma 2, equals the pivotal count for player 2 divided by n factorial, and so on. For Shapley-Shubik, using the applet is much quicker than following this process by hand, unless the question asks for a list of sequential coalitions. As a list for Using the applet is much quicker than following this process by hand, unless the question asks for a list of the sequential coalitions. The applet can be found in my MATLAB by selecting Multimedia Library and then Java Applets, and then Find Now. The Shapley-Shubik applet is one of the 2 applets listed under the Chapter 5 subheading. Now, let's jump into our examples for this section. Question 1. The table provided below shows the 24 sequential coalitions with pivotal players underlined in a weighted voting system with 4 players. Find the Shapley-Shubik power distribution of this weighted voting system. First, find the pivotal count for each player. I will highlight each pivotal player as I count. For player 1, looking for the Looking at the player ones in each coalition, the pivotal ones, remember, are underlined. There's 1, 2, 3, 4, 5, 6, 7, 8. So the pivotal count for player 1 is 8. For player 2, 1, 2, 3, 4, 5, 6, 7, 8. Pivotal count for player 3, 1, 2, 3, 4, 5, 6, 7, 8. Now, if you're looking at the list, right, here's our list here, you can see that we counted a pivotal player in every coalition. There are none left. We've accounted for all the coalitions. This means that the pivotal count for player 4 is 0. The Shapley-Shubik power distribution then is sigma 1 equals 8 over 24 equals 1/3. Sigma 2 equals 8 over 24 also equals 1/3. Sigma 3, again, 8 over 24, third, and sigma 4 is 0 over 24, which is 0. Question 2. We will use the applet for this one. It works the same way that the Bonsaff Power applet worked. Open up the Shapley-Shubik applet, and if you've not used the Bonsaff applet, pause the video for a minute and read the directions on the first screen of the applet. Select the Shapley-Shubik tab at the top of the applet. Question 2. Find the Shapley-Shubik power distribution of each of the following weighted voting systems. Part A, 111, 90, 40, 30, 2. I'm sorry, 90, 40, 30, 20. Okay, so select add row until we've got space for all 4 players. Let's put the weights in, 90, 40, 30, 20. And the quota, 111, select compute, look at the pivotal count column. 16, 4, 4, and 0. All right. Pivotal count for player 1, 16. Pivotal count for player 2, 4. Player 3, 4. Player 4, 0. So the Shapley-Shubik power distribution, sigma 1, 16 over 4 factorial, if you remember, is the total in this case, that's 24. That's 2/3. Sigma 2, 4 over 24, that's 1/6. Sigma 3, again 4 over 24, 1/6, and sigma 4, 0 over 24, which is 0. Part B, 119, 40, 30, 20. The only thing that changed was the quota. It changed from 111 to 119. So open the applet back up, change the quota from 111 to 119, select compute. Look back up at the pivotal count column, 16,440. Well, that is exactly the same as it was for part A. Let's have a look. 16,440, no change. Why are the power indices the same? Let's think about the situation in part A. The quota is 111. Player 1 in either player 2 or player 3 is a winning coalition. The coalition player 2, player 3, player 4 is not a winning coalition. So any coalition must have player 1 in order to reach the quota and be a winning coalition. In part B, even though the quota changes from 111 to 119, none of these things change. P1 and either P2 or P3 is a winning coalition, and any coalition must have player 1 in order to reach the quota and be a winning coalition. As a result, the power distribution does not change. Part C. 121, 90, 40, 30, 20. Before we enter this into the applet, notice that this time a coalition of just P1 and P3 is not a winning coalition. Right? 90 and 30 is 120, that doesn't make it. This is different from parts A and B. Expect the distribution to change. All right, let's open the applet back up. Again, the only thing that changes is the quota, this time from 119 to 121. So change the quota, select compute. Look at the pivotal count column, and indeed it did change. This time it's 14, 6, 2, and 2. Pivotal count for player 1, 14. Pivotal count for player 2, 6. For player 3, 2. And for player 4, 2. So the power distribution, sigma 1, 14 over 24 reduces to 7 over 12. Sigma 2, 6 over 24 reduces to a quarter. Sigma 3, 2 over 24 reduces to 1/12, and sigma 4, 2 over 24 reduces to 1/12. This completes our video on Shapley-Shubik power distributions. So long as you have the terminology down, you are ready to do the homework for this section.